Hi, good morning, everybody. I'm going to be doing a walkthrough of those bottom 6 problems on page 2 in the homework packet. So, folks, we are going to be using our calculator sometimes to just check ourselves on these, but for some of them, we're going to be purely using our calculator. So, first, a quick note. When we type these in on our calculator, we need to trap every binomial and trinomial in parentheses. So, I'm going to go ahead and show that work on my paper, because that's exactly how you would type these in on your calculator. Now, in the notes, we talked about top heavy, bottom heavy. Same. This is also something we talked about in the last chapter at the end of the last term. And this is for pure rational functions. So pure rational functions, top heavy, has slant asymptotes, bottom heavy has a horizontal asymptote at y equals 0, and then same has a horizontal asymptote at y equals the ratio of the leading coefficients. And we can also check ourselves with this on our calculator. So this is actually what we did in the chapter before we learned about these rules. And the nice thing about this is we can find it without using our calculator. But when in doubt, you can always type these equations in on your calculator to get an idea of what the end behavior is. So I'm going to go ahead and type in this first one, making sure I have those parentheses. And when I hit graph, there's what my function looks like. So we can see that it looks like as we go towards negative infinity, that maybe it's leveling off at 0. And as we go towards positive infinity, it is leveling off at 0. I can also use my calculator table ask to kind of guess or estimate my way around this too. So if I go to second window to the table settings and change my independent to ask, then I can go to the table and I can start plugging in very, very large positive numbers. And this shows that as I go towards infinity or get larger and larger and larger, it does look like I am getting smaller and smaller decimals or closer and closer to 0. And if we start testing more and more negative numbers, I just did the same one twice. We can see the same thing, that we are getting very, very close to 0. So we can tell graphically, we can tell from our table ask, and we can also tell from using our pure rational functions asymptote rules. So if I look at my degrees of the top and degree of the bottom, the degree on the bottom is larger. So this would be bottom heavy. So we would have a horizontal asymptote at y equals 0. So if you can determine where the horizontal asymptote is, that will tell you the end behavior as well. Now, slant asymptotes, those are going to be a little bit trickier because we aren't going to know whether they're going up and to the right or down and to the right unless we do that long division, which is kind of a nightmare. So we'll get into what we have to do if it is top heavy. So my end behavior is 0 for both of these because we are leveling off towards that asymptote as we go towards negative and positive infinity. Okay? So moving on to number 2, if I type this equation into my calculator, so it definitely looks like there's a horizontal asymptote or something that we are leveling off towards negative infinity or towards positive infinity. And the nice thing is, if I already have my calculator with that table ask engaged for those values, and go to second graph, we can see that it automatically fills those ones I used on the previous problem. Now, remember, folks, when you have a horizontal asymptote at anything other than 0, sometimes your calculator gets goofy and rounds it a little bit too much. Folks, if I'm plugging in different inputs, should I be getting the same output? No, plugging in 1,000 is definitely going to get me something different than 10,000. So your calculator is just like, yeah, close enough. It basically gets to -3. So if you start start seeing the same digit, that's just your calculator trying to over-round. So from our table ask, from our graph, we can see that as we go towards negative infinity, it looks like it's leveling off at -3. And as we go towards positive infinity, it looks like it's leveling off towards -3. But how could we figure this out using our pure rational function rules? If you were comparing the 10 and the 5x squared, which is what a lot of students try to do on this one, you're like, hey, it looks like it's bottom heavy, so wouldn't it be 0 and not -3? The issue here, folks, is that the top of this fraction is not written in standard form. I'm not comparing the 10 to the 5x squared. I'm actually comparing the -15x squared to the 5x squared. So comparing those degrees, this would be same degree. And so we find the horizontal asymptote by taking the ratio of the leading coefficients. And the leading coefficients, remember, come from those degree terms. So this would be a horizontal asymptote at y equals -15 over 5 or -3. And ta-da! That's how we find that end behavior limit. So again, folks, on these pure rational functions, knowing these shortcuts, that's going to be important for calculus. However, if you ever forget these shortcuts, don't forget that you can check yourself on your calculator. And I like to refer back to the calculator so that you can visually see what end behavior is and what it looks like. All right, so moving on to our next problem. We've got another pure rational function. So if I look at my calculator, so it definitely looks like there's a horizontal asymptote somewhere in here. Maybe it's at 1, maybe it's not at 1. So if I go to my table, so it looks like it's leveling off at about maybe 0.6 repeating or possibly 2/3. So on number 3, this is why using the rules does have its benefits, because back in the first chapter we looked at horizontal asymptotes, we would just have to kind of guess what these decimals were as a fraction, but using these happy little rules, we can now find exactly where that asymptote would be. So if I compare my degree of the top and the degree of the bottom, we see that this is another same situation. So we have a horizontal asymptote at y equals the ratio of the leading coefficients, or 2/3. And we can see that that is consistent with what those decimals are showing on our calculator. So as we go towards negative infinity, we are leveling off at 2/3. And as our graph moves towards positive infinity, we are leveling off at 2/3. Ta-da! Now on number 4, the instructions on this say to, hey, use a calculator. And if you're like, well, why can't we use top heavy, bottom heavy, same here? It's because, well, actually we can use it on number 5, but these ones are a bit more complicated because they, number 4 and number 6 are not purely rational functions, because I've got base e involved, so an exponential piece to the function. And on number 6, we have a square root involved. So on number 4 and number 6, these rules are not going to work because they are not purely rational. Number 5, we are going to use the rules. It is purely rational, but because this one has a slant asymptote, instead of using long division to figure out the equation of that asymptote, we're just going to use our calculator to visualize where that asymptote is. So folks, let's go ahead and look at number 4 and typing this equation in on my calculator. We get this. Now, as we go towards negative infinity, it looks like our graph is leveling off towards 0. And as we go towards positive infinity, it looks like my graph is leveling off, so maybe at 3 or 4-ish, just from kind of eyeballing it from my graph. Now, if I go to my table ask, this is interesting because for larger and larger positive values, we are leveling off at 3.5. But for larger and larger negative values, we start getting an error. So this is kind of interesting. So we're going to go ahead and try to figure out what is happening with this problem. So if I look at this, and this is kind of what we did in the notes with thinking about plugging in those values of negative infinity and positive infinity. If I take negative infinity and plug it in for x, we would get 3.5 over 1 plus e to the negative